So a while ago, during high school, me and my friend wanted to make a turn-based roguelike. And long story short, we had some plans, we tried some stuff, but ultimately, and I'm speaking mostly for myself, I've just been too lazy to get the project to the finish line. Basically, too much procrastination due to feeling overwhelmed, since that was my first game dev project, and other excuses. Going back to the present now, I got a YouTube recommendation about how to make a roguelike in one day by Mrs. And that reminded me of that one time I tried doing the same, and decided to give it another shot, following the guidelines in the video. Now, my video will build on that and provide more information about how I decided to structure the project in Unity, but the game is mostly going to both look and play like Mrs. one. I mean the sprites, the room, etc. His channel is in the description and on the screen. I definitely recommend checking him out if you're interested in game dev, which I guess you are if you're watching this video. His videos are to the point and full of useful information. So yeah, this video is quote-unquote a tutorial of sorts, I guess. Not really though. Disclaimer, if you're interested in specific topics, hopefully I remember to leave timestamps in the comments so you can find the chapters. The game we're making is a 2D turn-based roguelike which uses the Unity tilemap system. You play as a wizard that traverses a procedurally generated dungeon, has to pick keys to unlock doors to get to the next level, and can use potions to summon magic to harm his enemies. Let's go over the movement logic. We have two tile maps, one for all the walkable areas and another one for walls and doors, but I'll talk about those later. Since the game is turn-based, I've decided to use the queue data structure for this, as it has two very useful functions, which are the front and enqueue. Front gives us the object that has been stored in the queue the longest, and enqueue stores an object into the queue at the last position. After every object's turn, we put it back into the queue if it is still active. All the objects that are in the queue are subclasses of a base abstract actor class. They need to implement the abstract take turn method themselves. Next turn happens after an action is invoked. For the action, I have a class which inherits from a scriptable object. Every instance of this class serves as a channel through which data is shared. For this specific case, the only data sent is the fact that an event has happened, like unit's turn ending, but we won't know which unit ended its turn. Basically, while every actor will invoke the action once its turn has finished, Turn Manager will listen to the set void channel and it will start the next turn. This architectural choice keeps the classes quite decoupled and makes it so that if something needs to be tested, I don't need to add any extra objects. In the game, there are three actor subclasses: enemy, projectile, and player. Starting off with the player, I want to quickly mention that in order to align the player with the tilemap grid, the script uses two functions: world to cell, which converts a world position to a cell position, and get cell center world, which returns the world coordinates based on the grid cell. Basically, since I want the actors to live as separate game objects, I firstly need to get the closest cell on the grid from their position, and then adjust said position so that it aligns perfectly with the grid. Quite redundant, I know. As for the player movement, I'm using the new Unity input system. I have a custom input action asset with one action map and two actions, one for moving and other for shooting in 4 directions. Since everything is turn-based, the action type is button. When the take turn of player is called, a boolean value is set to true so that the conditional statement in the update method can execute if player presses necessary keys. With the input system, we first initialize new instance of player input actions, which is the name for my input asset. In the update method, the specific keys are accessed using this syntax: input reference variable dot action map name dot action name dot triggered. I do this for both the movement mechanic as well as the shooting mechanic. Since the actions are set up as 2D vector, think WASD, the value of said vector can be obtained using input reference variable dot action map name dot action name that read value, and then you insert the type of the value you're trying to read, which in my case is going to be vector2. And if you want to find out more about this, just search generics in C#. Now I'm going to digress a bit from other actors and their logic, because I want to introduce the projectiles by talking about how the player fires them. Firstly, on the map we can find potions. When a different object collides with these, using onTrigger enter 2D, we check whether it's a player by comparing the tag. You can set up a tag for any game object. If it is a player, we store the type or color of the projectile to shoot. Both adding ammunition and shooting will update the player HUD. Now, just like with the turn manager, we do not need a reference for the player HUD component if we use the scriptable object delegate channel approach. Meaning, if I have a scene where I don't want to show the player HUD, I don't need to change anything in the script. I just want to add the HUD. and the player logic won't produce any errors. Now the projectile itself is of type actor, and it just moves in one direction until it has reached the wall, or if it has collided with an enemy. The enemy needs to be of the same color in order to be hurt by projectile. This brings me to an issue I've created because I use two different timing systems, so to speak. First of all, we have the physics collisions that are managed by Unity, and then there is my turn manager with a queue and a delay. Now before, I had an intermediary method that was asynchronous, aka had async keyword used in its declaration. That method was used to call the next turn after an actor's turn has ended. This sometimes made it so that projectiles didn't register enemy collision and the bullets just went through. I managed to fix it by turning the async function into IEnumerator and always waiting for at least one fixed update. Now I won't be going into detail about enemy AI since I've used what Mrs. recommended, which is Bresenham's line algorithm for detecting the line of sight, and A* for the actual pathfinding. As for knowing the player's position, again, same scriptable object channel architecture. As for the more minor objects in terms of class size, like stairs, keys, and doors, we can start off with stairs, which detect collisions and just generate new dungeon based on the level player is in. Keys update player counter, which is used when opening doors, which block the stairs. I've also implemented a way to track the highest score. It's super crude, and I've given it the least thought and research. Basically, we can use application.persistent data path to store persistent data regardless of the build platform. If you want to easily create longer strings that you store as a data that will be accessed later for loading, you can use an instance of string builder and play around with three of its methods: clear, append, and toString. For example, my game stores the highest score in name:_score format. So to load the score, I just use the string split method to divide the file contents between :character and try parse method of integer for the second part of this split to get the score value. Now, just like Mrs.'s video, my dungeon generator also adds the JSON grid nodes to a list and chooses randomly from them. As for converting images into levels, I wanted to pre-compute color data into scriptable objects, thinking it will make everything faster during playing. Maybe it did, maybe it didn't. I haven't really gotten around to trying out Unity's profiler and stuff, but basically you can take an image data using sprite reference variable, .texture.getPixels, and as parameters, you just put in the starting and ending borders of a rectangle within that image. Then you can iterate through the colors, use some conditional statements, create an instance of your scriptable object data structure using scriptableobject.createInstance, initialize its values, and store it as a permanent asset using assetDatabase.createAsset, and save it using assetDatabase.saveAssets. If you put all of this into onValidate method, and just in case surrounded with #if Unity editor block, you don't need to do any manual work except for coding everything, which is always acceptable as a programmer, even if it's going to take longer than what the manual approach would. But that's pretty much it. There might be things I've missed about the process since I forgot to record most of it, but yeah, I had fun making this game and hopefully I'll finish another game into the future. To be fair, even right now, I have this immense feeling of imposter syndrome. Imposter syndrome. Since basically I took ideas someone else had, added a twist on them with the projectile color, and called it a day. But it has been like that with most things in my life lately, I mean, especially with coding. So I thought that by making this, it will help me alleviate this feeling, and I guess it did, at least partially. But yeah, just wanted to say one more time that you should watch the original video too, if you got time. Anyways, thank you for watching, and if you enjoyed this type of content, like and subscribe, and I'll see you in the next one. Bye bye.